Hey guys, so today we'll be constructing new Taylor polynomials, and in particular new polynomials that you won't see on a normal sheet or some sort. So I'm going to teach you how to work it out. So basically the first question is, using this already constructed Maclaurin series, determine the new Maclaurin expansion of 1 on 3 plus 2x cubed. So basically you want to get this into the form of that. So you'll take out the 1 on 3 as a common factor. You keep going down, and then you'll have to do a double minus to get this in the terms of a negative. And then from there, you'll be doing a back substitution of let t equal negative 2 on 3x cubed. Once that substitution is made, you can make this side equal the left side up there, and then from there you're able to substitute into the series, and that will be the final answer of the new Maclaurin series. This will only work for all values of less than the absolute value of negative x.
Alright, so today we're going to, following on from part A, using what we just found in part A, we need to find the new Maclaurin polynomial for this function. So this function is the derivative of this function which we just found in part A. So it's making a little bit of sneaky substitution. Find the derivative of this using chain rule. Take the 1 1/3 in the front, bring power down, multiply by inside the brackets, and you end up with this new Maclaurin polynomial for that function. This polynomial is only valid for absolute value of x less than 1, because of this value which we found, this polynomial in A, which was only valid for that same condition.
Okay, now in part C of the question, we need to find the Maclaurin series expansion for this integral here, and then we need to use the fourth Maclaurin polynomial to approximate the integral of this function. Now to start with, we know from A that this function here gives the Maclaurin series here. So therefore the integral of this function will be equal to the integral of the Maclaurin series. Rewriting that down here, we take the sum of the integral of this function, which we can then integrate to give this value here. Now as we sub in x and 0, we know that 0 is going to be nothing, so we end up with this final answer for the first part of 4c. Coming down here, we now sub in x equals 1/4 for our definite integral, and we now have n equals 4 as we're using the fourth Maclaurin polynomial to approximate the integral. So subbing these values in, we end up with this equation, which we can then simplify down to equal 2.264 times 10 to the minus 10.